Hello Bobcats. In this video we will be discussing ionic compounds in aqueous solutions. Now remember, aqueous means dissolved in water, so we want to discuss what's happening to an ionic compound when it is dissolved in water. Now what does happen is what's called dissociation. And dissociation is when ionic compounds dissolve in water and the ions are separated. Okay, so when we see an ionic compound that is represented as aqueous, we need to think that it is dissociated. So an ionic compound or ionic compounds that are represented as aqueous, or has this AQ with it, then you need to think immediately that they are dissociated. Okay, so whenever I see aqueous with an ionic compound, I think these ions are dissociated. And what do I mean by dissociated? So let's take sodium iodide. And if I have sodium iodide and I say that ionic compound is aqueous, then these ions are dissociated from each other or separated. So we have a sodium 1 plus, that's aqueous, and an iodide 1 minus, that is aqueous in solution. So these are dissociated ions. So whenever we see an ionic compound as aqueous, we dissociate them. So what is happening when we have a dissociated ion? Oh, and let me state this too. Ions that are all ions, even though I wrote aqueous here, but ions are understood. In other words, it's understood that all ions are aqueous. In other words, an ion does not exist. A charged species does not exist unless it is aqueous. Okay, are understood as aqueous. As aqueous. So a lot of times when I'm writing reactions out, I don't put this little aqueous symbol next to the cation or the anion, because they don't exist unless they're aqueous. So it's understood that they are aqueous and that these ions only exist in solutions. And so ions only exist when they are in solution. And why is it that they only exist when in solution? Well, it's because of what water does. So if I look at water, and I have a water molecule, so we have water is bonded with one hydrogen and another hydrogen. So it's got this kind of bent shape. And the electrons in this shared bond, the electrons are shared unevenly or unequally, and most of them it's shared unequally towards the oxygen. So the oxygen has really what's called a partial negative charge. That little delta sign means partial. It's not a complete negative. It's not like this up here where it's an ion. It's a partial negative. And this side of the water is partially positive. And we say that water is a polar molecule. Polar meaning you have opposite ends. So we have a partial positive and a partial negative end of water. It's polar. And polar molecules can dissolve polar substances. So let's say I have my sodium ion here and it's in water. So there's my sodium ion right here. And the water molecules surround the sodium. So the negative end, which is the oxygen end of the water, will surround and protect that sodium ion and pull it away from all of the other ions in the crystal. And then the iodide ion over here is also surrounded by water, but it's surrounded by the other, or positive, partially positive end of water. So water creates what are called solvation cages around these ions, and you can think of them as protecting the ions. And these ions do not exist as charged species unless they are protected by the water. So ions only exist when they're in solution or dissolved in water. Otherwise, when you remove the water, these ions are then reattracted to each other and they become an ionic compound solid with the crystalline structure. So when we see this, whenever I see something like a calcium chloride compound and it's got aqueous written next to it, I immediately think that there is a calcium 2+ ion, and since there's 2 chlorines, we have 2 chloride ions. So whenever I see this aqueous, this is what I'm thinking. Or when I see something like this, Pb, lead 2 nitrate, PbNO3, 2, and it says aqueous, immediately I'm thinking a lead 2+ plus 2 nitrite or nitrate ions, 1- ions. Now, how would that look in a beaker if I were to think about this as on a molecular level? So if I have a beaker of water, now we don't show the water molecules, but what we understand is that there's going to be 1 calcium 2+ ions and for every 2 chloride 1- ions. So these ions are just floating in water, okay? And it's a 2 to 1 ratio, or 1 to 2 ratio of those ions in water. And then for the other one, just like this one here, what I'm thinking is this. We have, in my mind, I'm picturing water in the beaker, and there is 1 lead 2+ ion, Pb2+, and then 2 NO3 1- ions. Okay? Now we're not showing the water molecules surrounding them, but you have to understand that water molecules are surrounding each one of these ions and dissociating them from each other, keeping them separated from each other. So it's very important to understand that whenever we see aqueous with an ionic compound, you must think of the separate ions. The other thing is that we would like to look at, there's 2 more. There's one that's called ionization, which is very similar, and it works with acids. So an acid goes through ionization, which is the same as dissociation, but specific for acids. Because acids really are not ionic compounds. They're molecular compounds that have ionic behavior. So ionization occurs when an acid is in solution, or you see an acid is aqueous. So if I see H2SO4 aqueous, immediately I think that they are ionized, and so you get 2 moles of H1+ ions and 1 mole of SO4 2- ions. So they're ionized from each other, which is the same as dissociation, and it's this H+ that makes the solution acidic. Okay. So acids ionize. And the last one we need to be aware of is called autoionization. And water, autoionization occurs with water. So autoionization occurs with water. this doesn't happen to a large degree, but it does happen, so you need to be aware of it. But water, H2O, I'm going to write as HOH, and it's not aqueous, it's a liquid, but water is very special, and it auto-ionizes into H plus ions plus OH minus ions. But not a whole lot of it, just some of it. But if I add an acid, what I do is I increase the H plus, or if I add in a base, I increase the OH minus. So increased H plus in solution makes the solution acidic. And an increased number of OH minus, if you increase OH minus, it makes the solution basic. Okay. So we have dissociation for ionic compounds. That's when the ions completely dissociate or separate from each other. We have ionization, which occurs in acids, and that's when an acid ionizes or the ions separate from each other, the H plus and the anion. And then there's auto-ionization, which occurs with water. So there's on a lower level or a lesser extent, water will also ionize into H plus and OH minus. Now, one thing I'd like to make sure that we're clear about is when we have coefficients. So let's say I have a coefficient that says I have 3 moles of aluminum chloride that is aqueous. Well, that would dissociate into, I would multiply, that's 3, so that's 3 Al, 3 plus ions, and then 3 times 3 is 9 plus 9 Cl, 1 minus ions. So we need to be aware, and remember, officially I should be writing AQ next to these because they're aqueous, but you must realize that anything that is an ion or has a charge, it has to be aqueous. And that will be the end of this video. See you next video.